Yeah. Oh. Yo, 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 yo. Oh. Alpha, beta.
Hello, in this video we are going to look at a likely examination question in physics. We will use a plane mirror and 4 optical pins to show how light reflects from a mirror. Let's get started. You have been provided with a drawing board, a drawing sheet, thumb pins, optical pins, plane mirror, and other necessary apparatus like the pencil, a ruler, and a protractor. With the aid of the thumb pins, fix the drawing sheet on the drawing board. On a sheet of drawing paper, draw the horizontal line MN. We are using this diagram as a guide. So we are drawing the line MN. So we have M here and N there. Draw also the lines NL1, NL2, NL3, and NL4 such that MNL1 is equal to alpha equals 100 degrees. So we are measuring 100 degrees at point N. So we put the points here at point N and the line here on the baseline, and we measure 100 degrees from this direction and put a point there. Then we draw a straight line with this point and point N. And we name here L1. The angle here is alpha. So MNL1 is alpha, which is 100 degrees. Draw the line BO making an angle of 45 degrees with MN. We put a point here and name it O. This side will be the reflecting surface, so we shade the other side. And angle MOB, we are drawing BO making an angle of 45 degrees with MN. So you put the protractor here, the point here on O, the line, baseline on the horizontal line. Then we measure 45 degrees from this direction. Put a point there. And with point O and this point, we draw a straight line. This is going to be the incident ray, and we name here B as shown in the diagram. Erect two optical pins at P and Q as shown in the diagram above. So we erect two pins on the line BO and mount the plane mirror on the line MN. Mount the plane mirror on line MN. Use the two other optical pins to trace the path of the reflected ray OC by erecting one at R and the other at S. So we are going to erect two optical pins to be in a straight line with the images of these two pins in the mirror. So the two pins in the mirror and this pin are in a straight line. So we'll fix another one to be in a straight line. So now the two pins and the pins in the mirror are in a straight line. Remove the plane mirror and mount it on line NL1. Then we remove the pins at P and Q and use them to trace the path of the reflected ray CK by erecting one at T and the other at U. So we are going to use these two pins to trace the path of these two optical pins looking through the mirror from this side. So we want these two pins in the mirror to be in a straight line. Then we simply put two other pins in that line. So as you can see, the pins in the mirror and the pins outside are in a straight line. Remove the pins and join the line OC and CK. So we remove the pins. This is point P and this point is point Q, and the angle here is 45 degrees. This point here is R and this point is S. We have point T here and point U here as shown in the diagram. So we draw a straight line passing through R and S. to O. This is a reflected ray, and we draw another straight line passing through U and T. So we name here K as shown in the diagram. The meeting point here is C, and this is also a reflected ray. And we are going to produce the lines BO and CK to meet at V. So we name here theta and here V as shown in the diagram, and we are to measure angle theta between BV and KV. So we put the protractor on the line BV such that the baseline falls on line BV and the point here on V. Then we measure from this direction, and we have theta is equal to 20 degrees, and the alpha over here is 100 degrees. And we are going to repeat the procedure with the mirror on MN and NL2, MN and NL3, MN and NL4. For angles of alpha, we are going to change the alpha to 110 for L2, 120 degrees for L3, 130 degrees for L4, and find the corresponding values of theta. So now we are going to draw another line here, MNL2, but this time we'll measure an angle of 110 and get the line L2, and then repeat the procedure to get the angle theta. Do the same thing for L3 and L4 with angles of 120 degrees and 130 degrees respectively. So we have the tabulation of results here. This is alpha, the unit is degrees, and theta, unit degrees. So the alpha, we use 100 110, 120, 130 degrees. And when we measure theta, for 100 we have 20, 110 we have 40, 120 we have 60, 130 degrees we have 80 degrees. So this is the table, and we have to plot a graph with alpha as the ordinate, that is the vertical axis, and theta as the abscissa, that is the horizontal axis. So we draw the vertical and horizontal axis, and we are plotting alpha on the vertical axis and theta on the horizontal axis. So we are going to choose a scale. We choose a scale of 2 centimeters is to 5 degrees on alpha axis. So on this axis, we can start from 90, since the least value is 100, and we keep on adding 5. So we have 95, 100, and so on. And on the horizontal axis, we choose a scale of 2 centimeters is to 10 degrees. So we can start from 0. So we have 0, we keep on adding 10, so 10, 20, 30, 40, 50, 60, and so on. And for the first point, we have 100 on the vertical axis. This is 100, and 20 on the horizontal axis. They will meet here. The next point, we have 110 on vertical, 40 on horizontal, meeting here. 120 on the vertical, this is 120. 60 on the horizontal, so they will meet here. And the last one, we have 130 on the vertical axis and 80 on the horizontal axis, so they are going to meet here. So we draw the line of best fit. Determine the slope S of the graph and the intercept on the ordinate. Okay, so for the slope, let's draw this horizontal and vertical lines forming a triangle with a line of best fit. The slope should be as big as possible. Let's name here A, here B, and here C. Now the slope is change in BC over change in AB. For change in BC, we have C minus B. So C is 130 degrees minus B 95 degrees. And for AB, we have B minus A. B is 80 degrees. A is 10 degrees. And now 130 minus 95 degrees is 35 degrees. 80 degrees minus 10 degrees is 70 degrees. And when we divide 35 degrees by 70 degrees, we have 0.5. And for the intercept on the ordinate or on the vertical axis, that is where the line of best fit cuts the vertical axis, and clearly that is 90 degrees. So the intercept on the ordinate is 90 degrees.
Yeah.